Hi, my name is Nawar Alongir. My ZID is Z5543506, and this is my student ID card. Hopefully, you got it. Let's dive in. The video that I'm making is for the classifying galaxy experiment. Let's dive in. So, as you can see, these are the table of contents, what I will be featuring in the next few minutes. Let's move on. The very first question was, what do we understand by galaxies? Galaxies formed early in the universe as small, irregular, clumpy systems. After the Big Bang, gravity pulled matter together into dark matter halos. Then, the gas fell into these halos, cooled down, and formed the first stars and baby galaxies. Over billions of years, gravity kept pulling these galaxies together. They merge and interact, and this slowly shapes them into spiral and elliptical galaxies that we see today. Some galaxies keep a lot of cold gas and have many blue young stars. These are usually spiral galaxies, and they are still forming stars. As galaxies evolve, they use up their gas and slows down the formation process, and that is elliptical galaxy. Let's move on. In this slide, you can see two pictures. One of them is Coma clusters, and the other one is Hercules clusters. We can see both spiral and elliptical galaxies in them. The spiral galaxies usually look blue or white, especially in their spiral arms. This tells us that they have young stars and active star formation happening right now. The elliptical galaxies, on the other hand, look more yellow, orange, or even red. That means they are mainly made of old stars with very little star formation going on right now. So, are both elliptical and spiral forming stars? No, not really, right? Spirals are still forming stars, but ellipticals, on the other hand, have very little gas left, right? So, no new stars are forming. Which group is really older, if you ask? Elliptical galaxies, obviously, because they have already passed the main star forming stage, so most of their stars are old. Let's move on. I also looked into interacting galaxy system NGC 6745. In this image, the shape is very distorted with long tail and pulled out materials. There are many bright blue patches distributed throughout the region. These are starburst region where young stars have recently formed. This happened because two galaxies collided or passed very close, compressing gas clouds and triggering new star formation. So what did we learn? We learned that when galaxies interact, they don't only change shape, they also create brand new stars. That's a new information, right? Now, as we move on, we can see a table. In the table, I have placed for each clusters 20 galaxies and label them as spiral, elliptical, or irregular. I also classified 20 galaxies from Hubble Ultra Deep Field. In this, you can see some of the numeric value. Their elliptical galaxies were most common, especially near the center of the clusters. Look at them, there's 12, 15. On the other hand, the spiral galaxies was there, but usually more towards the outer parts. Irregular galaxies were there, but rarely. Let's move on. But in the Hubble ultrafield deep field, it looked very different. Irregular galaxies were very common. Many galaxies in the Hubble ultrafield looked small, clumpy, and distorted, which suggests they are young and still forming. This supports the idea that galaxies often starts out irregular, then over billions of years grow, evolve into spiral and elliptical through star formation, interaction, and merging. So, what will happen in the future, like 10 billion years, what would we see? That was the question, right? We would probably see fewer irregular galaxies because of many of them would have merged by now. Some of those would have formed new ellipticals. There would be less blue light because star formation slows down, obviously, as it runs out of gas. In other words, the galaxies would look older, redder, and more settled. The whole field would show a more mature universe with more big regular galaxies and fewer tiny clumpy ones. So, at the end, what did we learn? I learned a lot from this whole course. This project itself helped me understand how galaxy shape and color tells us about its age and star formation activities. I learned blue light usually means young stars and active star formation, while red light usually means old stars. Let's see. And this is the end of my whole discussion and the video. These are the references that I've used for this assignment. Thank you very much. I'm signing out, and yes, thank you.